Hello, hi, welcome to lesson number 3. My name is Thomas Enoru, and today's lesson we will be talking about the methodology or learning about the methodology for wetland vulnerability analysis. Wetlands, like any other ecosystems, are also affected by many pressures due to human activity. The vulnerability refers to the relationship between exposure or the threats to a particular risk event, the impact of that event on the wetland, and ability of the wetland to cope with the impact or the efforts needed to minimize the impacts. So vulnerability of the wetland captures things to do with factors or threats that affect it, the levels at which these threats impact on wetlands or affects the wetland, an ability of the wetland ecosystem to cope with these impacts over time. The concept of coping capacity or the resilience and sensitivity are included as part of the vulnerability, since they are especially important in the context of changes in ecological characters of a wetland. So due to climate change and anthropogenic activities, basically human activities on wetlands, looking at only the threats alone does not help you to measure vulnerability, but also you have to look at the resilience, or basically the conditions or the state of a wetland, the current state of the wetland in helping itself withstand or mitigate these adverse effects on it. Now, analysis of vulnerability in terms of threats on wetlands is crucial to understanding their impacts on the health of the wetlands. This in turn leads to the development of suitable wetland management strategies. Now, every country in the region of East Africa and to the local level are devising different management strategies to combat the effect of the threats on wetlands. But it's very important for them to understand the level at which each wetland that they want to combat or manage is in terms of the threats or the factors affecting it. Wetland vulnerability analysis is part of a broader process of wetland assessment, which includes gathering and analysis of information needed for decision making. So information here is very key to combat the effect of climate and human activities on wetlands. Analysis is also necessary, more especially in Africa or East African wetlands, where their health in terms of ecosystem services is increasingly under threat from various drivers and pressures. So the threats that we mentioned earlier could also be categorized as drivers and pressures, which we shall look later as we go along this lesson. Lastly, wetland assessment requires collection and analysis of huge quantities of spatial and non-spatial data. So data can be quantitative in nature, but also qualitative in nature. And it can be spatial or non-spatial in nature. Basically, the spatial aspects looks at the general, it has an aspect of location information in it. And the non-spatial information relates to datasets or information that doesn't have location aspects within it. So for one to conduct a vulnerability analysis of wetlands, they need to ensure that they have a collection of data sets that can help them run this analysis. So why do we carry out vulnerability analysis? Why should this management arms of government within the East African countries conduct the vulnerability analysis? One is to identify systems that are of a great risk. Wetland as an ecosystem has different systems that governs or that it lives on. We could talk about things like hydrological systems. We can talk about ecological systems of their own, looking at the plants, the regeneration and so forth of the wetland system. So we carry out analysis of vulnerability of a wetland in order to see of all the systems that it has, which one is at a greater risk. Two is to aid in identification of factors that make a wetland vulnerable. So external factors are also those aspects that cause an effect on wetlands. And these factors, we need to understand which factors are they and to what level are they affecting the wetland. To prioritize, number three, resources allocation to most or the least vulnerable wetland system depending on the goals. So if we realize that this wetland A is more vulnerable than wetland B, then we can prioritize the resources and allocate more to wetland A since it is more vulnerable than to wetland B, which is less vulnerable. I would give an example. For example, if you look at wetlands that are located in urban centers, they're more vulnerable than probably some wetlands in rural areas. But also the level at which it's being degraded varies from location to location. The last is to estimate the inability of the wetland ecosystem to tolerate the stresses or the factors that are affecting the wetland over time and space. So the temporal management strategies need to be devised or generated in order to be implemented over time to combat the effect of the wetland. So that's the reason why vulnerability analysis is key, is so that one can be able to estimate the inability of that particular wetland ecosystem to tolerate the factors, human and climatic or natural in nature. So we need to say, okay, if performing wetland vulnerability analysis is important, how should it be done? The first on the top is to conceptualize the vulnerability itself. As far as the wetland ecosystem, the stakeholders and the experts in the wetland arena have to conceptualize vulnerability of a wetland. They go further to identify the indicator variables that are required for one to conduct the vulnerability analysis. Furthermore, they go ahead and identify and select the required datasets. So under vulnerability analysis using Earth observation data, which we'll talk more in the next lesson, the experts and the stakeholders, the experts could, we refer to them as people who have more knowledge as far as the wetland ecosystem is concerned. And the stakeholders, these are interested parties. It could be a government institution, it could be people at the district or local level that are interested in conservation, but also utilization of the wetland products and values that they can achieve from the wetlands. So under Earth observation analysis, these groups need to come together and generate the required data sets that can be used for analyzing the wetland vulnerability. The two groups should also be able to devise or generate the weighting of these indicator variables that will be later allocated to individual datasets for generating the vulnerability maps for a wetland. Now, one should also note that these datasets that they're generating must have the spatial characteristics or aspect in it so that it can be able to perform vulnerability of a wetland of a particular area. Now, after generating the required datasets and generating the weights that are required for it, the experts and stakeholders team conduct the normalization of the datasets. When they do the normalization of the datasets, they aggregate these datasets into a regular grid for each domain. So the domain that we are talking about will explain or elaborate on it further in subsequent slides. So when they aggregate these datasets and generate the regular grids for each of them, they perform a linear weighted combination in order to merge these datasets together and generate vulnerability units. The vulnerability units can also be considered as vulnerability classes, whereby you have class 1, which may refer to low vulnerability, class 2, moderate vulnerability or high vulnerability of a particular wetland. Now, before they finally generate the final output, they conduct what is called sensitivity and uncertainty analysis. So this analysis helps to see the level at which the datasets they have generated to what accurate are they, and what level of sensitivity does it put onto assessing the vulnerability of a wetland. So they could use robust models to generate this, which has already been implemented within the prototype of the wetland vulnerability analysis tool. And if they are satisfied, then they can visualize the final wetland vulnerability index map. But if they're not, then they go back and again, for the purposes of generating a credible, acceptable map, they will have to identify either more datasets or drop some datasets. Also, go back in the loop and generate the weighting or the weights that are meant to be assigned to these datasets differently. So in summary, the way of conducting the wetland vulnerability analysis is that one, the assessment team, which consists of the experts in wetlands and the stakeholders, conduct a conceptualization of vulnerability of a wetland. They identify the datasets that are required and also evaluate the weights that are needed to be assigned to these datasets. This is done because not all the datasets that they will have selected have the same effect on affecting the wetlands or the same effect of vulnerability on the wetland. They normalize these datasets in order for them to have the same values, the same direction of analysis, so that, for example, they will have a value of 0 to 1 in order for the same direction to be measured in the wetland for each data set. Then they do aggregation of these data sets, perform a linear weighted combination technique onto them to generate the vulnerability units of the wetland. Before they can accept the units, the final map, they have to conduct sensitivity analysis or uncertainty analysis on the datasets that they will have combined, and then visualize it finally as a wetland vulnerability index map. Wetland vulnerability analysis workflow goes into about 5 steps. In these steps, we have already mentioned that you do the conceptualization of vulnerability. You identify the factors that are related to the vulnerability, categorize these factors into domains of exposure, sensitivity, and capacity. Now, this third step is something that I have not talked about earlier, but you realize that when you generate all these data sets, you will have to then categorize them into 3 domains. These domains are wetland vulnerability factors. When you're measuring vulnerability, a vulnerability equates to exposure plus sensitivity minus the adaptive capacity. Well, different authors have a different approach. Others, based on the way the dataset was prepared, you could say equate vulnerability to be exposure plus sensitivity plus adaptive capacity. Now, then in the fourth step, you do the weighting or you generate the scores for each factor. That can be done using the SATI analytical hierarchy method, where you assign the different weights to different factors. We'll see it more below in the next slides. You can assign these weights between a value of 1 to 9 or 10 to 100, and then combine this, what we are now referring to be weighted factors or domains, to generate a vulnerability index map. So under conceptualization, one, it's a very important step during wetland vulnerability analysis because it helps you to identify the threats or the factors related to the wetland ecosystems. Also, it helps you to generate the wetland condition status or the wetland condition factors of the state of the wetland, and also generate the coping capacity or the management practices that can help mitigate the effect of these threats on wetlands. So the method should be based on the best practices of environmental assessment, and here we are referring it to this practice as the DIPSA framework. The DIPSA is an acronym of driver, pressure, state, impact, and responses. So under conceptualization of wetland vulnerability, one should adopt the best practice, and one of them could be the DIPSA framework. The DIPSA framework is used to assess and manage the different environmental problems. Now, the drivers under the DIPSA acronym is the socioeconomic and sociocultural forces driving human activities. And these activities increase or mitigate the pressure or the threats or the effects onto the wetland environment. Now, as humans, there are needs for that could be financial in nature, that could be food, that could be education, or they want employment, that they want to extract or to use in their daily lives to satisfy those needs. Now, these needs are the ones that we are calling the driving forces that will later increase or mitigate the pressures on the wetlands. The pressures are the actual stresses that human activities place on the wetland environment. So when I have a need, let's say my need is to have shelter, I will insert this need onto a wetland by constructing a house or an industry within a wetland. So these are the act of me constructing this building into a wetland is the pressure now I'm causing onto the wetland. The state now looks at the condition of a wetland at a particular time and space, and how this pressure that I'm inserting on a wetland affects the wetland, let's say through degradation, is measured by looking at the impact under the DIPSA acronym. The responses are the societal activities deriving policies to manage these wetlands or come up with the way these effects can be mitigated in a wetland. So when you're conceptualizing the wetland vulnerability, you have to look at a framework that captures all angles of assessing vulnerability, but also after doing the assessment or analysis of the vulnerability, and you've identified the level at which a wetland is vulnerable, you must then, that framework should be able to capture uh, the mitigation practices or the mitigation activities that can be done to combat these drivers or threats onto the wetlands. So the DIPSA framework, it captures all that, and it also allows for a negative feedback. For example, if you came up with a strategy under the response uh, time, the period at which you're doing response activities, and then you realize that these activities are actually not working as far as mitigating the human and climatic effect on wetland is concerned, then you can be able to go back and then derive another option or come up with another alternative uh, ways of checking these activities onto the wetland. And the beauty of the DIPSA framework also is that it's an interactive in nature, that you come up with a response and then you can quickly see the results of your response management practice onto the wetland. So number 2, under the steps of uh, performing wetland vulnerability analysis, is to identify the wetland vulnerability indicators. So the indicators we had mentioned about is the datasets that you will require. Under the Earth observation practice or Earth observation wetland vulnerability analysis, you must look at the datasets. First of all, consider them in terms of the scale, spatial scale. On the bottom, you can see that it could be global, national, or a local scale. And then you'll see that the different components of the DIPSA framework is being captured in this level. And the DIPSA framework is helping you categorize or identify these required datasets for assessing or analyzing the vulnerability of the wetland. So you could have, as you can see, the drivers looks at things to do with population growth, urbanization or settlements or built up areas and so forth, poverty, as far and then the climate change, and then the pressures are the land use changes, the agriculture and so forth. The states looks at the water quantity, quality, the sizes of the wetland and habitat fragmentations. And then the impact look at the wetland loss. It could be also the impact could be also the loss or the drainage of the water within the wetland, and also the habitat loss in terms of the species and so forth within the wetland. The responses then will then look at the management plan or the policies that are being created to respond to these factors or the effects that have impacted on the wetland. So the DIPSA framework still also, as you can see, it's playing a role here by helping us identify the wetland vulnerability indicators and categorizing them in terms of the pressure, the driver, the state, impact, and the responses. And as you can see, it's a cyclic way of approach that is being used to assess analyze vulnerability. But also there is a link between, let's look at the responses, has a link to the driver, and an indirect link to pressure, state, and the impact on the wetland ecosystem. So you must consider the level or the scale of analysis that you're going to perform. As you can see, all these data sets are within that can be at a level, the spatial scale of the global level, national, as well as the local scale. The third step in performing vulnerability analysis is to categorize the datasets into vulnerability analysis factors. Now, vulnerability, as I had mentioned earlier, looks at the things to do with exposure, uh, sensitivity, and the responses, or the coping capacities. Now, here, when you're going to categorize your data, the first is to look at datasets that are known to be threats. Under the DIPSA framework, these are drivers and pressures, and we looked at them earlier in the previous slide, and we saw population pressure, agriculture and wetlands, the drought as far as climate variability is concerned, the built-up area development. We see a lot of industries within urban sectors being erected within the wetlands. Also, there is an aspect of land degradation which captures aspects to do with evapotranspiration, the rate at which the soil is losing moisture. It looks at the erosion, the movements of the surface objects, the water, and so forth. Then you categorize data sets under the state of the DIPSA framework onto the sensitivity vulnerability factors. So here we have things to do with vegetation index that looks at the vegetation condition of the wetland, which is the state of that wetland. Another one is the water quantity state of that wetland, the quality state of the water of that wetland, and the ecosystem services. So if a wetland has, let's say, more of the wetland itself, more water, then it will have a high ecosystem service value for it than the wetland that has a lot of built up and agriculture or the cultivated areas within it. Now, then you move ahead, you'll be able, when you combine the exposure and the sensitivity, you generate the potential impact to the wetland, because you'll have looked at these threats and how these threats affects the state of a wetland. And then you go further and then look at the resilience after generating the potential impacts or categorizing those indicators into the potential impacts. Then you can also generate or categorize data sets under the resilience, which are the response factors. And this in under Earth observation, you're looking at data sets such as the wetland water dynamics. So a wetland that has ability to change its water surface extent has a higher chance of existing than the wetland that is reducing at a very high rate. Seasonality of the wetland, we see that a wetland that is more resilient will be one that is permanent than a wetland that has that is more seasonal, because then during dry season you'll find that there will be a lot of human activities being carried out within a seasonal wetland than a permanent wetland. But this varies with different areas and countries. You might find wetlands that have water throughout the year is more used, or there are more activities in that wetland compared to the wetlands that are in in that are permanent, that are seasonal. Sorry. So as you can see, this is an interactive process. Here, you're trying to identify the different data sets. Here, then you're trying to categorize them into the different vulnerability factors. But this is this is more to do with expert opinion. This is more to do with expert opinion. Now, to explain further these vulnerability analysis factors, exposure is basically the amounts and the rates of change that the ecosystem or the wetland system experiences from direct or indirect impact of disturbance. Sensitivity looks at the characteristics, the conditions of wetland system, uh, and it's dependent on specific environmental conditions and the degree to which it's likely to be affected by a disturbance. Lastly, resilience or adaptive capacity is the ability of the system or a wetland ecosystem to cope and persist uh, under the changing conditions. These changing conditions are being caused by the exposure factors. Now, the fourth stage is performing a combination and weighting of these vulnerability factors. So once these weights or the scores have been assigned to these factors, these scores and weights, remember, are being done by the experts and the stakeholders. So each country with the experts in wetlands will know exactly that this data set, let's say for exposure, population will have a higher weight uh, to the degradation or the drought, for example. So these weights are generated by the experts on wetlands and also the stakeholders or the people living, communities living around these wetlands. So the factors are meant to be multiplied with the domain, and then you conduct an addition. So as you saw previously, exposure data sets were quite many. So after generating the weights for individual exposure data set, you multiply it by the weight to it, and then conduct a summation or addition of those factors to create an exposure layer. And you do the same for the sensitivity layer and the resilience layer. This we'll see in the final lesson how this is performed within the prototype that has been developed for wetland vulnerability analysis. Now, after generating the exposure, sensitivity, and the resilience layer, you go ahead and generate the wetland vulnerability index. Now, the wetland vulnerability index will see that based on the location of a wetland, not all uh, not all the exposure, sensitivity, and resilience layers carry equal weights. For others, it may be, but for others, it may not be. So therefore, this, for example, looking at the sensitivity, a wetland that is located in a protected area will have a less weight assigned to the sensitivity layer compared to a wetland that is just in communal land, for example. So the weight is measured by the domain, and the domain could be exposure, it could be a sensitivity, or it could be the resilience. So each individual weight is measured, it's multiplied against that particular domain, and then the linear combination is done to generate the wetland vulnerability index, as you can see in the formula of WVI, meaning the wetland vulnerability index. So this is just an example of a selected wetland of Rufiji in Uganda, where we have the exposure, sensitivity, and resilience domain. Each factor or data for that domain is also categorized, where you have the land cover or land use. This is basically capturing agriculture and the settlements within the land cover or land use data. We have the population, drought, degradation, and built-up index. And each of these factors or data is assigned a weight based on the location of the wetland and based on the expert opinion input onto that. What is very important is that the total weight for each domain has to add to 100 and not less or more than 100, because each has to be in either in a percentage or on a scale of 1 to 9. So it has to add to 10 if you're using 1 to 9, or if you're using 0 to 10 to 100 as your scale of weighting the data sets. So based on this, when you're generating exposure layer, for example, or exposure domain, you'll multiply the land use, land cover by 20, population by 20, drought by 10, degradation you multiply it by 20, and built up areas you multiply it by 30 in order to generate the exposure layer. So when you add land cover, population, drought, degradation, and built up index, which has already been multiplied by individual weights, you will be able to obtain an exposure layer, and you perform that to the other data sets in the sensitivity and resilience domain. So after doing that, when you're combining the exposure, sensitivity, and resilience domain, they are also multiplied by the weights. So in this case, exposure will have a weight of 40 and sensitivity a weight of 40. Resilience will have a weight of 20, because the wetland has less resilience compared to the exposure factors. So what is to note here also is that the weights that you'll be supplying the different domains has to add to 100. Lastly, we want to see how are some of the strategies that can be used to address the issue of wetland vulnerability. One is to build resilience of these wetlands, associated catchments, to improve ecosystem services they provide. Wetlands, people benefit from wetland ecosystems through the ecosystem services. And the only way to mitigate the effect of human activities and climate change is to build resilience onto these wetlands. This could be through policies, this could be through recovering the boundaries of these wetlands, and then also try to improve on the catchment so that the seasonality of the wetland is improved towards permanence when the catchments are well managed well. The second strategy could be building resilience of communities to improve livelihoods and reduce dependency on wetlands and other natural resources. Now, this works well in rural areas, but in urban areas, it also varies with the level of development into that country. We see that wetlands that are located in developed countries are actually uh, more conserved in developed environments than in the rural environments, because uh, people who are financially stable or who have reached that state of who no longer depend on wetland for food and the water and so forth. They actually use wetlands a lot for leisure and recreation. So they tend to protect these wetlands more. So this resilience, building resilience will vary from one wetland to the other. But what is very important to address the vulnerability of the wetland is to build the resilience of the communities around it. Gazetting wetlands in Uganda, there is a lot of activities being done to open boundaries in quotes of the wetlands in order to demarcate uh, the wetlands so that people can know that this is where I should work and stop and not go beyond this. Promotion of awareness and environmental literacy. Of course, awareness is very, very key, because there's some people you might interact with who will tell you that actually they didn't know that the activities they are doing in the long run will lead to this wetland disappearing after time. So awareness is very key, but also to encourage communities to be on alert so that they try as much as possible to conserve these wetlands. Thank you for your attention, and thank you for going through the lessons and the courses. Uh, I wish you all the best, and also look up for the next lesson that will be touching on some of the concepts that we mentioned earlier. Thank you so much.